Good morning, everyone, and thank you very much for coming to the first sessions of the day. I'm Itaj Sodajar. NexTreams is my consulting firm. I've been involved in CMAF from day one on behalf of Microsoft, co-chaired all the development activities in MPEG, along with Krasimir, who Roger introduced in the first talk. Also, I started and been involved in Dash development in MPEG and also Dash industry from very first day, recently in CTA Wave, as we're going to see, and also several other related standard organizations, DVB, and so on. So today, I would like to talk about how we can use the CMAF to cut the cost and simplify the workflows. I think Roger talked about what CMAF is and what it can achieve. This is more about how you can achieve it, this talk. So the basic questions for cutting cost is that can we just use a single copy of the content to serve to all devices? You've been facing with devices supporting different codecs, different streaming formats, different DRMs, and that means that multiple copies of the same content. This doesn't mean that this doesn't cover the multi-rate, multi-track part of the case. For all of those, for all different versions, you have to have multi-track because you're using basically streaming using dynamic adaptive streaming. So you need for adaptations of the network having multi-rates of it, but having various formats has been a big pain, a big cost. It reduces the efficiency in terms of the delivery, as well as, in fact, impacts the user experience because it adds all this complexity to the platform, even in terms of maintenance, monitoring, deploying, it all's pain. So is there any way to reduce everything to a single copy meaning a single format? And CMAF started with that idea. The name is Common Media Format, common meaning that using the same format, the same media format for different streaming protocols. It started with basically Microsoft and Apple talking to each other. Is there a way to bring HLS and Dash together and have one common format for them? And the initial proposals basically was proposed to MPEG in February 2016. Several companies, probably around 30, 40 companies attended and co-developed the spec further. And finally, it was published officially in January 2018, just this year. Technically, it was frozen last July. Or July 2017. And as you can see, this was relatively very quick development. The goal was not to introduce a new format, but try to come up with a format that most devices can today are deployed can use it, and hopefully the additional technology you need to build on the existing devices would be minimal. The spec is 23,000-19, part 19, and it has the core specs. Right now, it has actually 2 amendments, another amendment, and a core is coming out. Basically, the second editions will be issued probably this year or early next year or mid next year. So what's the goal? You guys have seen this issue of multiple formats, HLS, Dash, Smooth to some extent, and HTS used to, but maybe very little. You need to deliver all this format, encode all this format with the manifest as well as segment formats, deliver it through the CDNs. Those multiple copies exist in CDNs, and each device supporting one of these formats getting the content from a CDN. Now, if we can eliminate HLS as it is, well, HLS TS, eliminate a smooth, eliminate HTS, and even eliminate all these copies that we have, and come up also with a format that it's common. Common meaning that the media segments are encoded once with the same format, but the manifest could be different. In the case of Dash and HLS, MPD and M3U8. If we can achieve that, then storage and packaging cost will be reduced. One single copy going to exist in the CDN, so more efficient caching, definitely reducing the cost of the deployment. And of course, one single copy of the content with two manifest files in different devices. If the device supports one of the manifest files, it can download one. It doesn't need to download both. Manifests are usually very light compared to the segments, media segments. So in terms of efficiency, that's not really a major issue. But usually, actually, the devices downloads one of the manifest, not two. So how CMAF wants to achieve this in terms of the core technologies? It uses fragmented MP4 or ISO-based media file format. It uses common encryption. Roger talked a little bit about what the goal of common encryption is, and as the word says, you encrypt once and you use it multiple DRM with it. We're going to talk a little bit about it. And it's not just using fragmented file, MP4 file format, but also putting file format and media content constraint in terms of how frames are packed as we're going to see chunks, fragments, and segments, what constraint you put on each of those, and what constraints you put on video codecs or audio format text. And then the reason for those constraints is to be able to deploy it in the different platform and achieve the functionality we need, be able to switch, for instance, dynamically between different tracks, be able to do random access, be able to do startups in the middle of the content. Of course, it covers several codecs, AVC and AAC, as basically we call it baseline HEVC, and a scalable HEVC is supported, as well as MPEG-H audio, which is basically the next generation object-based audio coding of the MPEG, and what is called USAC or XHEAAC, which is a very efficient coder. It covers a long range of encoding from 64 kilobits to maybe 500 kilobits, and it covers very good quality. So, and of course, it supports subtitles and captioning, IMSC, WebVTT, as well as CTA 608, 708. The core specs basically consist of those. Amendments consist of some of the advanced codecs. What I put as the baseline, we're going to see, it's basically the main presentation profile or baseline presentation profile. The way that the spec is developed is not tied to any specific codecs. While some specific codecs are listed here, the intention has been that any organizations or even a company can define their own CMAF with their own audio or video codecs. For instance, AO Media, if they want to support AV1 with CMAF, they can basically define a AV1 CMAF profile, which actually Netflix and others recently did in AO Media consortium. Same thing, for instance, with Dolby codecs or DTS. So what the media data look like in the CMAF? We start basically from what we call chunk. Chunk consists of one or multiple samples, whether those samples are video frames or audio samples. They basically are packed in a ISO-based media file format called ISO-based file format segment or fragment. And because of they are a fragment, they have a header called move, basically says what it includes. It can have an event message box, EMSG, what Roger was talking about, being able to include time, sparse time data, with the media, and it has basically a stream type. Now, you get the chunk, you can concatenate all of them, multiple of them, one or multiple of them together, and you use a different stream type, you get a fragment. The difference between chunk and fragments is that chunks can start with either IDR or non-IDR. So the chunks, for decoding a chunk, you may need previous chunks. But fragments always starts with the IDR frame. So each fragment can independently be decoded. Basically means that the first chunk also starts with the IDR. Now you have chunks, you can put them multiple chunks together and build a segment. And then, of course, you have a identifier in terms of the S-type, stream type, to identify the segments. And in order to play any of these, you need, of course, a header. The header basically has decoder initialization information, which consists of the file type and what is called a MOV box in ISO-based media file. Now, those are basically the building blocks of the CMAP. What you deliver, basically what resources you put it as a resources on the internet, you basically assign them a URLs. It could be three different things. One, the entire media track. So basically you put all the fragments together, one single file, and you can deliver the entire movie. Or the client can come using byte ranges, get different parts of it. What Netflix is doing today is basically single track file encoding. Each movie consists of one single file. The client, when it starts encoding, there is a box called segment index, which defines basically different ranges of the basically media. It downloads that, and based on that, it does do a HTTP byte range request. So it gets piece by piece, downloads it, and starts playing back. The other alternative is that each of those segments, instead of being together, be in the separate file, have a separate URL. So you have a manifest that describes segment 1, 2, 3, 4, and it says how it comes. HLS playlist, as Roger was describing, or MPD, is basically also doing that. MPD manifest can also do a single track file too. The third options would be, instead of delivering them as an entire track or segments, you deliver it as chunks. The big difference between chunks and segments is that chunks are usually much shorter. And as I said, they don't necessarily need to start with the IDR. So in terms of encoding, even multiple chunks build the segment. Chunks are efficient in terms of each segment. If you wanted to encode the segments as short as each chunk, because you have to insert the IDR in the beginning, the byte sizes of those chunks would have been large. So for low delay latency, basically we use chunk delivery. And there are different ways of delivery. I will talk a little bit about that. Whether you assign a unique URI to each chunk, or actually use a still segment address, but you use the chunk transfer mode, it depends on how you use what addressing schemes you use in your manifest. Maybe we talk a little bit about that one too later. So as I said, each of those objects, media format, they have identifiers. Those identifiers are recognized by brand. So a CMAF track, a CMAF segment, CMAF chunk, and CMAF fragment gets their own brand. So when you get when the client gets, a player gets a segment or a chunk, it looks at the file type or S type, and by looking at the brand, it knows what type of media objects it received and it can play. Of course, this was just describing coding of one version or one bitrate of the content. And for delivery, we need multiple bitrates. So you can consider all those encodings also happen in the different bitrates, what we call switching sets, assuming that you have here 2, 4, 6 different bitrates. Say it starts from 2 megabits per second, comes down to 500 kilobits per second. The the main characteristics of the switching sets is that the fragments need to be aligned, time aligned. So as you see, for instance, the fragment n with the different encoding bit rates, it starts at t and finish at t plus duration n. Same thing for the next fragment and so on. So you always see this alignment. And the reason for alignment is obvious. It enables you to switch, or the client to switch between different bit rates. Depends on the availability of the bandwidth, network bandwidth availability. It switches between the bit rates in order to be able to continue streaming and not getting to rebuffering or a stall mode. So we define what the file format constraint is. How do you put, or what you define, what codecs, what you put in CMAF? In CMAF language, each specific codec tied to a CMAF file format is called a media profile. So, for instance, there is a media profile for HD using AVC codecs, high profile level 4, that it uses CFHD brand, and it can contain video coded to the maximum width and height of 1920 by 1080 and maximum frame rate of 60. And with color primaries and characteristics VES of 709. There is another media profile for AAC that basically, again, it has a specific file brand, and it defines what codec it uses, what the profiles of the AAC is using. And for closed caption, same thing, for instance, for IMSC1. So each of these are one media profile. And if you look at the CMAF spec, as I said, it includes several different codecs. So it's AVC, not only one media profile, multiple media profile with different, basically, profile and level, and also height and width. Same thing with HEVC, scalable HEVC, MPEG-H audio, and USAC or XHEAC. Now, in order to play a content, you need more than just one media types. You need video, audio, maybe subtitles. So you put these together, what we call a CMAF presentation profile. The spec only defines one single presentation for profile today. It's called baseline presentation profile. And it has its own identifier, CMF HD. And basically, it consists of AVC, the profile is shown there, AAC, the profile shown there, and of course, IMSC1. So putting these three things together, you create a presentation profile. So if you signal that your content have CMF HD, you know exactly what you need to decode the content. The baseline CMF HD profile comes in three different flavors. It could be unencrypted. It could be encrypted with CTR, basically common encryption plus CTR, or it could be encrypted with CBCS, what Apple uses for encryption. As I said, if you go and look at the CMAF specs, look for 23000-19. The official or one is published is January 2018, but it has, you need the core specification, amendment 1, amendment 2. There are some work going on. There's going to be an amendment 3 and a small core agenda. And there are also some still exploration work going on in MPEG. But basically, in a year, we're going to have a second editions combining everything together, so you're going to have a single spec. So let's go back to our question. Does CMAF give us enough features to create a single copy? Basically use it for HLS and Dash and maybe even other formats. The answer, well, in terms of reducing the cost, at least in terms of the media format, instead of doing HLS and TS and doing Dash and MP4. Basically, you can, as I said, do only MP4, no HLS with M3U8 manifest, and dash with manifest file. So in terms of the file format, we have a common file format. It reduces the cost. In terms of the content protections, we used to have basically encrypted payloads for each DRM, DRM-A, DRM-B, DRM-C. Each of them were using their own encryption, their own custom headers. And of course, the value of the common encryption is that you encrypt it all the same. You have different headers for different DRMs on the same file. So you have a single file. So everything looks great on the slides, but what's reality? So does CMAF give us a single copy? The reality is this, yes, it helps in case of format, one common file, track, segment, or a fragment format. But still, we have many media profiles. If you encode in HEVC, devices who support AVC, you cannot deliver the content to. In terms of audio, you do not only have AAC, but also you have Dolby and DTS. And also in terms of encryptions, even CMAF itself, it has two encryption modes. So if you have to encrypt it in CBCS for Apple devices and then CTR for all other devices, then still you need to have two copies. So CMAF was a great step to bring formats together, but it is not the final answer. So what do we do next? CTA started a project called WAVE, Web Application Video Ecosystems, and the goal of this project has been to solve what they call it, at least the objective, to solve commercial OTT video issues. But one of the issues, of course, is the common format. So basically, WAVE project has three different legs. One is coming with the content specifications that solves the issues of the CMAF. A device playback capability, meaning that CMAF is just a format. Similar to the dash, it's a content format. They don't define the client behavior and the client requirement. You can drive some of those requirements from the format itself, but there are other operational things that all the client needs to do the same. So you have a reasonable or consistent behavior when you do the playback. So there is a device playback capability that it has a testable requirement. And it goes even further. It defines a spec for application environment. And it's built based on HTML file. It defines basically what features of HTML5 to use to build the application that devices support. And at the end, WAVE will provide a test suite that you can do test, the conformance test on the content, the device playback test in terms of playing back the content, and also whether a device browser supports all the features that is listed here in the application framework spec. So this is intended for instance, especially for embedded devices, for TVs, for phones, for game consoles. If they support this, and then maybe we have one common experience, then building applications or building services, delivering the media content would be much easier. Maybe we achieve one single copy. So in terms of what WAVE consists of, it consists of several standards. Of course, on the web media API specs is heavily relies on W3 specs. Is basically the basic experience has been going through the major browser implementations, the 4 code base that it's there, and profiling what elements and attributes are implemented by them and cataloging them and then building the test tools for them. So when you run that test tool of web media on, say, an embedded device, you know whether what which tags are supported, which elements are supported, what it's missing. It also relies on MSE EME, so it enables basically using JavaScript player. You don't need necessarily to have an embedded player. If the device supports those two, you can download the player. And on the other side, it has a content specs that is basically CMAF. It relies on a little bit of Dash, but also we talked about HEVC, ABC, and so on, because CMAF is referencing them. And it has codecs that are not MPEG codecs, like DTS, Dolby AC 3.4, and of course, HLS. List of the companies are involved in this activity. It started maybe 2 years ago. It very quickly became a large activity. And what we are concerned about today is the WAVE content specification, whether it solves the problem of multiple copies. So as I said, WAVE content specifications is built on top of CMAF. What Roger said, WAVE to CMAF is similar to -IF to Dash. WAVE, you can consider it an industry forum for deploying CMAF in a practical way. So the content specs consists of basically the CMAF specification references the CMAF specification, some profiles of the CMAF that is in the spec, not all, because we want to limit the number of profiles to build, so achieve more interoperability. And it has some additional profile that some codecs are highly popular outside of the MPEG ecosystem, but it's useful to have profile for them, Dolby being one, DTS, and maybe AV1 in future. So one important task that WAVE does with the companies being there, it looks at each media profile with the objective of how much market relevance they have, how much they being used, whether they are MSE compatible, because then an environment like HTML5 plus JavaScript, you can use it for having JavaScript players to basically play the content. And this is an ongoing process. It's not a one-shot thing. Every year, they're going to be a spec adding media profiles that are more popular or becoming popular. Say a new codec sees a lot of adoption. So as you can imagine, the spec also lists a list of media profiles similar to Dash. It has similar to CMAF. It has some of the CMAF profile, which basically everything here you see for the video is actually a subset of CMAF. And as there is normative references here to the CMAF. And then it has audio profiles that you can see. Some of them are basically AAC, but there is the DTS HD, there is AC3 and AC4. And even MPEG H. So basically, you have different codecs. And of course, also there is a IMSC text closed caption profile. Same thing that it's in CMAF is also WAVE is supporting. So WAVE helps in terms of reducing the number of profiles. So still, it's a good a step converging to one single profile. But WAVE specification today supports both CBCS and common encryption. As you can imagine, because of the deployed devices today, some of them support CBCS and some of them support CTR. It was really hard to converge on the single one. While there are lots of service provider wants to converge to a single one, in terms of a specification, both are defined there. So still, the question is what will happen in terms of encryption. But let me, before that, WAVE also goes one step more than CMAF. CMAF, each presentation is basically one CMAF presentations. It's one duration of time. WAVE defines a WAVE program as a concatenation of multiple CMAF presentations. So CMAF presentation 1 followed by CMAF presentation 2 and CMAF presentation 3. This is what we see in Dash as periods, period 1, period 2, period 3. In HLS, basically discontinuity tag at the boundaries between CMAF presentation 1, CMAF presentation 2, discontinuity tag from CMAF presentation 2 to CMAF presentation 3. And what's important here, WAVE defines some baseline splicing constraint that when you go from one presentation, CMAF presentation to another CMAF presentation, what constraint do you need to follow so that the client can continue playback and you don't have blackouts, you don't have either a stop playback or because of switching codec, for instance, few seconds blackout, or you hear audio glitches. Right now, the constraint is defined, is very, very much constrained. Basically, the constraint practically says that the codecs should be the same. The headers that you have initialization segments for CMAF presentation 1 should be such that you can also use it for CMAF presentation and so on. But this is basically the first step, and there are going to be more advanced splicing constraint. Part of WAVE challenge was to support the devices that are deployed widely today and then introduce features for devices in future. It wasn't just forward-looking or backward-looking. Therefore, it has these two modes of what we can support today, what we can support in a couple of years. Things like add insertions, of course, program changes, you can basically do using WAVE programs. Just the roadmap, you see recently in April, actually, this year, the content specification was published at NAB. Amendment 1 is coming in this month, and they're going to be content validator tools. Also, the other aspects have been published, the other two parts of at least the web media snapshots. The HTML5 basically profile was published in April. So now go back to our basic question is that does the WAVE spec give us the single copy? If we implement everything based on WAVE, and if devices all support WAVE, it does. Again, it helps in terms of reducing the media profile, as I said. But we have still two encryption modes. The good news is that it seems, well, Apple is supporting CBCS, PlayReady, and White One are supporting both CBCS and CTR. There are devices in the market can just do CTR, but since PlayReady and White One are supporting both, it seems that in a couple of years, maybe we're going to have basically all devices supporting CBCS. So I think practically industry is converging on one encryption mode, and I think that's a good news for all of us. And well, what about the manifest? There hasn't been any work on converging the manifest. I don't think there is actually a way to converge the manifest. But these are basically program descriptions in different formats. There are pros and cons of each. As for instance, Roger was talking about in HLS, you cannot change the number of bit rates you have for each for each media track. So if you have 4 bit rates encoding the first part, if you do discontinuous, you cannot switch to 3 bit rates, because if you go from, say, a content to add. In Dash, you can do anything you want. You can splice it anywhere you want. You can change the number of representations or tracks you want. There are things that maybe in HLS you can do simpler in terms of just describing it. It's a simple playlist. Dash is more sophisticated. It has more features. But reality is that for most common use cases, I think translations from one to another is not that difficult. You can even do on-fly translation from one manifest to another one. I think it would be good to see in few years which manifest wins. I don't think really would be win for any company. I think it's again it's an industry where it goes, but it would be see what type of advanced applications you can do with any of these, and whether one has any advantage to another. Low latency. This has been a hot topic recently. as you've seen, there was a question also in the main or starting talk, plenary talk. So the HTTP streaming is great. It's basically, you can use HTTP, all the infrastructure, existing infrastructure, CDNs, reliable delivery. You can do also buffering, so in input buffer in the client, so you don't need to do stalls or rebuffering. But then it comes with the cost. It comes with the latency. HLS recommendation, I think, is segment durations are 10 seconds. So the average latency you get about 30 seconds. In Dash, we can do better. I've seen implementations to 4 seconds or 2 seconds segments. You get 6-second segment latency. Can we do better? And that's what's important, is really end-to-end latency. It's a difficult problem. But in terms of the encoding, we believe you can. We talked about segments, fragments, and chunks. And we said the difference between chunks and the other ones is that chunks, they don't start with the IDR frame. So they are dependent to each other in terms of the decoding. They could, but they are much shorter, much smaller. It means that in terms of durations also they are shorter. So instead of having, when you encode a media as a CMAF fragment, you have to encode all the samples in the fragment, then put it out. So the encoder's output would be at the end of the fragments. In case of chunk decoding, at the end of each chunk, the decoder can put out the chunk. So the delay from capture to encoder output would depend on the chunk duration and not fragment duration. Chunk could be much shorter in terms of duration. And using that, then the question is that, so you have smaller building blocks, but how you deliver those smaller building blocks. One popular way, it's using HTTP chunk transfer. Let's assume that, say, contributions or the camera, the encoder encodes everything in chunks, and it uploads every piece of chunk, every chunk at any moment that it encodes. So the packager and origin server builds the segment as it goes on. You don't get the entire segment. You gradually get chunks, and you build the segment. What the client can do, it can request for the entire segment, but using HTTP 1.1 chunk transfer mode, the origin server can respond with the first chunk and say it's coming, and keeps basically sending the incoming chunks to the client. If the client built to decode each chunk as it comes on, then the latency would be as is shown here. If it was purely based on segment delivery, the start of the playback going to be here, so you have a latency of this much. While in the chunk delivery, you save at least 1 segment duration. Of course, there is the input buffer in the client that you put that basically buffer the input so that if the bandwidth goes down, you don't go to rebuffering. So, but the combinations of a short input buffer and chunk delivery can reduce the basically end-to-end latency. What ranges can we achieve? This work is in progress. There have been demos that people doing 1 frame chunks, basically 1 frame of video chunks at a very high available network, bandwidth network, in the local network, and so on. Those are more for demos. The ranges probably would be 2 to 6 seconds delay. And then this is trade-off. This is engineering. Shorter chunks you do, the chances that you do rebuffering if you don't have good networks, it becomes higher. How the CDNs need to support also chunks versus segments and so on. But in terms of the protocol, in terms of the building blocks of doing this, HTTP 1.1, already all the web servers supporting the protocol. Encoding CMAF in chunks is already in the specs. Lots of actual encoders already supporting it. It's a matter of building and deploying the service. DVB, along with Dash IF, recently did actually a great study, a commercial requirement study, and look at all different use cases in terms of sports broadcast, news, game, not two-way games, or different use cases, and came up with basically a set of requirements that if OTT streaming wants to compete with other conventional media delivery like broadcast, how much the latency should be, what's the maximum latency it needs to support. And depends on who you talk to. There was European broadcaster a lot be involved, but again, overall, it seems that like 5 seconds, 6 seconds even, end-to-end latency, it's a reasonable latency to be able to compete. I need to mention a little bit about Impact Dash. So the good thing about CMAF is that what we call Dash Ready. Dash has lots of features. Now it's in 3rd editions. Roger was going over the new features of HLS they added in the recent different tags, and I was thinking, each time he was going over one, I was thinking, okay, how we do it in Dash, how we do it in Dash. You can do all that with Dash, and you can do more. There have been lots of work. So in terms of features, Dash is really rich. Deployment has 2 major challenges. One, players building the features that are needed for the common or an advanced use, and then building experiences using those features. For instance, doing tiles, as Roger showed, doing ad insertions with, say, target-based advertisement, personalization. You can do all those. Tile streaming, you can do all those 360. So at the end, I just want to say that this work has been achieved by lots of organizations and lots of companies working together. If I count the number of companies have been involved in different organizations, probably it's going to be 70, 80, 90. In terms of Dash development, I remember every meeting we had like 100 engineers attending and basically submitting specs, arguing and improving proposals and improving the specs. So basically, Impact, Dash, and CMAF, DVB has been very active, basically it has a Dash profile, HBB TV, which is basically OTT service for the broadcasters in Europe. It's using DVB Dash, which is basically aligned with Dash and CMAF. Dash Industry Forum, of course, it has a lot of guidelines on Dash and CMAF. ATSC for 3.0 is using Dash, and now they are looking at basically how they can reference CMAF. And Wave, we talked about what they are doing. And this had happened just because of the industry collaboration. Still, in terms of deployment, I think there are lots of interesting use cases people can deploy that people have not deployed it yet. So it would be very interesting to see all those use cases, like getting the feedback, what works and what doesn't work. This was my presentation. Thank you very much. Questions? Yes, there is a mic.
I'll walk the mic around.
Thank you.
Hi, James Field from Multimedia. Can you comment at all on the royalty pools or MPEG-A liabilities and the differentiation between CMAF and Dash from an implementation, and should people be worried about that?
Okay, as of a year ago, I was working for a big company. I could not comment on any of them. Now that I have my own consulting, I can. There is a patent pool announced by MPEG-LA. What we know is there is a patent pool announced by MPEG-LA on Dash. What it claims to cover is just the manifest and not segment format. So at this point, there is no patent pool for segment formats, no CMAF. Whether in future would be, we don't know. Whether even the current patent pool, how much of the common core use cases of Dash it covers, I think it should be left to the people whether they need to license it or not. And whether that patent pool will be successful, yet to be seen. Success of patent pool is that go to look at AVC licensees. the list is long in terms of the number of company licenses. That's a success patent pool. Dash, I think, yet to be seen. What I can say is that since I've been involved in Dash from very first day, there have been lots of contribution in Dash from major companies. Microsoft, Netflix, Qualcomm, Ericsson, and a lot of those companies, all I named, either they said that they're not going to charge for the IP, or they are not at least in the patent pool. So, yeah. Again, this was a known lawyer answer to your question, so just take it with a grain of salt. Any other question? Yes, please.
So I'm not familiar with Wave. Great introduction, thank you. Is Wave focused on the media segments, or is it also include the manifests?
On?
Manifests?
No. It right now, it's just, as I said, it's just CMAF and extending CMAF and putting constraint in terms of the media codecs. No manifest. The idea is that manifest, dash IF, and dash define MPD. HLS is already defined by Apple. Use those as specification. Use those manifest with, and as I was saying, I think practically, as I said, you're going to have two manifests for a long time, and converting one to other in common use cases, not on the advanced one, is easy.
So Wave has no opinion about the manifest?
Not yet. Personally, I think it would be beneficial Wave with Dash IF and with Apple. Apple participates in Wave. They come up with some guidelines of how to use the manifest, but they haven't published anything yet.
Thank you.
I think that's all the time we have today. So if you have any questions, go ahead and meet out in the hall as we get set up for the next session. Thank you again.
Thank you.